Okay, welcome to CS628, Data Science using Python. This is our Unit 3 lectures, that's data preparation. So in our previous lectures, we said the data science methodology, the first phase is understanding the problem, and our second phase is data preparation before we apply algorithms or the model on the data. Or if we are doing classification or supervised learning, we need to build a model using the data set. So before we do that, we have to make sure there's no error. The data is perfect. So the goal of data preparation is, again, try our best. If there's any data mining or data science tasks, or if there's any error, we will do our best to, again, remove them or at least minimize them. So for data science or data mining purposes, here we say that database values must undergo data cleaning and data transformation. And normally in machine learning, we may go more detail on this topic. For example, the concept of dimensional issues. If we have a very high dimensional data, which we call the dimensionality curves, we can do our best to reduce it by using example PCR, that's the principal component analysis, or singular value decomposition. Here we are not going to discuss more details on the theory. Our goal in this course is how we can use some of the Python data science packages to solve data science problems. So we say data often from legacy databases where values will not look at in years. So maybe the format may be changed or expired, no longer relevant or missing. And the major goal of data preparation or pre-processing data is to minimize what we call the garbage in, garbage out, GICO. Now, if we can remove errors from our data task, so here we say if garbage input minimized, then the garbage in result may be minimized also. And normally data preparation takes 60% or more of effort for both data mining process or data science also. So in this lectures, data set, again, UCI is a University of California, Irvine Machine Learning Repository. And we have the link. So in this data set, they have 4 predators, which is our independent variables: the age, education, previous outcome, days since previous. And with these 4 predators, we can know the type of response the customer may have. This is for bank customers, whether they will respond or not. Direct marketing campaign of a bank interested in whether contacts will subscribe to a term deposit account. So with the first phase of data science task, which is problem understanding phase, our main objective here is that we want to learn the characteristics of those who bank with us, the characteristics of our customers that bank with us. Then we need to develop a method of identifying the likely positive responders. The positive responders, we are going to quantify them at expected profit, maybe cost. How do we translate the objective into a data science problem? So a very good example here is that we can use exploratory data analysis, or EDA, for graphic relationship among the variables to find if there's any relationships. We can also use the clustering to determine whether there are any natural grouping within customers. The concept of clustering algorithm is if all customers who have the same attribute may be clustered together. If they have different attribute value, let's say they are all university graduates, they will be clustered together. If they are high school graduate or they are not university graduate, they will be clustered together. One of our attributes is education level. Or we can also use, and then next we are going to develop a suite of data science models. So we need to decide which algorithms we are going to use. For example, decision trees, random forest, neural network, logistic regression. Now the algorithm we choose will be depends on the attributes, our data types. For example, if my target variable or most of my variable are categorical, I may use decision tree. If they are quantitative or numerical data, then I can use neural network or logistic regression. Also, we're going to evaluate each based on the predetermined model evaluation criteria. Then we consult with the management regarding to the best model with which to move forward with. So we may decide that maybe neural network is better than the rest of the algorithm that we use. So in these lectures, again, we focus on using Python data science package. We are going to learn how to add an index field. An index field will be like a unique ID, let's say a customer ID, or even a social security. In a school, we may have a student ID. Student ID is a unique number for each student. So two students cannot have the same ID. Most records or most real-world data sets may come without an index field. In databases, then we use the term primary key field, the field that uniquely will identify each record. So we're going to learn how to add an index field and also how to change the misleading field values. Maybe the values are too small or too big, and we can lead us to error. Then also re-expressing, that's changing or converting categorical data to numerical data. We can also use a concept we call the discrete. Also standardizing the numeric fields and also identify the outliers. Here we are going to standardize our numeric field using the z-score value. So first we start with adding an index field. Here we say the augment data with new variable to enhance understanding. That's the goal of adding an index field. Now we know that not all data sets come equipped with an ID field. When we say ID field, again, we mean the field that uniquely we identify each record in the database system. So here we are going to add an index field to the data, and it's going to serve as two purposes. First, it's going to act as the ID field for the data set. So without such a field, if such a field doesn't exist, without such a field. Now, if we have ID field already, then that's fine. And also we can use it to track the sort order of the records in the database. So we can be able to sort by using, especially if the ID field is in a numerical order, the sorting will be more easy. So we often repartition and also we resort the data. So this would be very helpful to have index field so that we can recover original sort order when we desire it. Now, how do we use Python to add an index field? So the first thing we're going to do, again, we are going to import the Python package pandas. So we start with import pandas as PD. So PD will represent. So next we say pd.read CSV. We import pandas because we want to use the read CSV method. So here we have the directory where our bank marketing training data set is, or the file. It's in the C drive, some folders, etc. So next, here we have read our data set from the bank training or bank marketing training. And now the data set is in the bank train object or variable. So next, to find the number of records and columns we have, remember now we have the bank train consists of our bank marketing training data sets. So we use shape, so bank train dot shape, and that will tell us again the number of records. So the dot shape will give the number of rows, which is the number of records, and also the columns. So in our data set, we have 26,874 rows, which means 26,874 customers. So next, we can create a new variable that assigns every record a unique integer. So here we are using the PD again, dot series. And now we say the series will be a range from 0 to 26874. So this will give us the range, each value in order 0, 1, 2, 3, all the way down. So here we say the series method and the range method will create a string of numbers from 0 to the number of records we have. And this will serve as a new variable index by assigning the output to the index variable of the data set. So here we have bank train, which is where we have our data set. We have a new field now called index. And this index, we have values from 0 to 26874. Now, if we want to view the data set with its new name, we can use the banktrain.head. So this will give us the index with all the data set below it. So the output to contain the first and the last 30 records for every variable in the data set. Now, the next, we are going to change the misleading field values. So to change the misleading field values, here we said, if the field days since previous, this is one of our attributes, days since previous, is a count of the number of days since the client was last seen, contacted from the previous campaign. Now we found out that most of the data values are near 1,000. So with a minority of the values near 0. So we can see the difference. So 999 is for customers who had not been contacted previously. Now around 99. So we need to change the field value 9999 to missing. So here, how to change the misleading field values using Python. Again, this time we are going to import the NumPy package as NP. We have bank train consists of our data set. And the field that we want to change, days since previous. So that's our attribute. So the attribute here will give us days since previous. We are going to replace 99999 with NAN. As we said, 999 means it's not present. We say 999 is for customers who have not been contacted. They are not yet being contacted present. So instead of using 999, which can be misleading, we don't know what it means. It can mean the number of days since previous or any. But if we use NAN, this means not available or not present. So we replace 999 with np.nan. We'll find each 9999 and change it to NAN. We can also create an histogram using the hist function or method. So here we can see they were using, we have the bank train, that's where our data values are. Days since previous dot plot. We use the dot plot method. What are we plotting? The kind is histogram. What is the title of the plot? Is histogram of days since previous. So the argument of the dot plot method is specify the kind of plot we are chart, and also the title of the chart. So here we say dot plot. After the variable name, we make a plot of the variable. Then the kind equal to HIST, we specify that the histogram should be made. So our plot should be histogram. Then we have title. So here we say contain in single quote. We create the title of the histogram. The next is the re-expression of categorical data as numeric. And this means we are going to change the categorical data, for example, false to 0. 0 is numeric, and let's say true. Instead of saying true or yes, we represent it as 1. So, and again, most of the time, the reason why we may re-express or change our data type may depends on the algorithm we are using. As we said earlier, if we have categorical, especially categorical target variable, we cannot use regression analysis or even neural network, we can't. So here we say the education field is categorical because we can see the education field is here. Either you are illiterate, you have 4 years basic college degree, or 6 years, which are this is 4 years elementary, etc. You have a university degree or professional course, etc. So this is categorical value. Now we are going to change it to numeric value. Basic 4 years means 4 years. Basic 6 years, 6 years. Basic 9 years means 9 years. If you finish high school, it's 12 years. If you take a professional course, it's 12 years or 12. And then university degree also is 16. So we are converting the categorical value of type of education level to numerical value. So transforming the data value to numerical values. The table here again shows how we accomplish this. Now this is the Python, how to re-express categorical value field values using Python. So here we say we replicate education, then we name it as education numeric. So you can see what we are doing here. We have bank train education. We assign it to bank train education numeric. So next we set up a dictionary to convert education numeric to a numeric value. So we have a new Python object or variable, DICT ed, which will be the dictionary education. So first one, we have a string for education numeric, then illiterate is 0, basic.4y is 4, basic.6y is 6, basic 9y is 9, high school 12, professional course is 12, also university degree. So here we can see that using the curly brace open and close, in each before the column is to the column we should have the numeric and also the categorical. So this is education numeric, which is the new name. Illiterate, categorical, numeric will be 0. Basic.4y, categorical, the numeric will be 4, etc. So the next thing we're going to do is specify the recoding in the following order. We have the variable's original value column, the variable new name. So the variable original value is illiterate, the new name will be 0. High school, the new name will be 12. Then we use patterns value for the missing numeric values. So this is the reason why we are using uppercase N, lowercase a, uppercase N, because in Python this means a missing value. So unknown, instead of having unknown, I can write np.nan. The np, the reason why we are using the NumPy package. So next is how do we standardize the numeric fields? Here we say certain algorithm perform better when the numerical values are standardized. The goal of standardized numeric value is the same concept as normalize. We may have large value and very small value. So what we do is that we combine all these values and find the mean. Then we subtract the mean from each value and divide by standard deviation. And that will give us a new value for, if the first value we use, then that will be a new value for the first value. The second value, we take the S2 minus the mean divided by the standard deviation. So when we have the data set, we can be able to find the mean and standard deviation, which will be constant. So we say the data value minus mean divided by standard deviation. Now, if your Z value is positive, it means the number of standard deviations above the mean, the data value lies. Negative Z values, the number of standard deviation below the mean. So normally the value will be positive if the value is greater than the mean. It will be negative if the mean is greater than the value. So how do we standardize numeric fields using Python? Again, here we can use the SciPy package. So from SciPy import stats. So when we import stats, we will standardize the age variable and save it as a new variable named HZ. So we have the bank train, which is the file name where we have all our data. Then the variable name now is HZ. Then we say this equal to the stats.zscore. So we use the zscore method and we are looking for the zscore. Here we are changing the age values, standardize the age values. So the attribute. Now if it's weight or the attribute is whatever it is, we have to specify. So the zscore will calculate the z value of the given variable. In this case, the variable of the age, we have over 2,000 records, all will be changed. So as the zscore command is part of the stat package, we write the command as stats.zscore. So zscore belongs to stat package. And we save it as a new variable in the data set named HZ. So the name is HZ. Next is how do we identify outliers? So here we say using the Z values to identify outliers. So record with extreme values, very small or very large, are called the outliers. So outlier, if Z value is greater than 3 or less than -3. So the number of contacts represent the number of customers' contacts. The number of contacts represent the number of customer contacts. So if the mean is 2.6 with a standard deviation of 2.7, then the number of contacts Z will give me number of contacts minus 2.6, which is the mean divided by the standard deviation. So the customer contacted 10 times, we'll have the Z value 10 minus 2.7 over 2.6 over 2.7. 10 contact is not identified as an outlier using this method. So we should consult with client regarding what they want to do with outliers also. So how do we identify outliers using Python? We can use the function name query. So use query function, and the query function normally identify rows that meet a condition. So I have bank train dot query. My condition is I want the age Z should be greater than 3 and age Z should be less than -3. So this requires records to have age Z greater than 3 or less than -3. Then we can use this record to create a new data set. So bank train outline is equal to bank train query HC greater than 3 and also HC less than -3. Now we can also sort the data set bank train outlines by its HC variable. So here we have bank train sort, bank train dot sort values HC. So we sort by HC. And the sorting will be descending order. Ascending order is equal to false. So we're going to sort by descending order. So here we say the sort value again, sort the records based on the specified variable. So we sort in descending order by specifying the ascending equal to false. So that will be the conclusion of our lectures. Again, we're going to have another lectures on data preparation, which we will go more detail in the theory. Here we just want to again use some few Python package to see how we can perform a task data preparation. So again, wish everybody the best and thank you.